So hello everyone, welcome to our workshop, Advanced Data Visualization with ggplot2. And I'm Wenbing Guo, I'm from Bioinformatics program. So if you have any questions about the slides, the workshop materials, you can email me. This is my email address. So a little bit about the notation of the slides. The code will pseudocode chunk will start with this little arrow. So basically, if you see such symbol, you can directly copy the code and paste it into your RStudio console. And the link is underlined. You can click on the link to see what kind of a reference I provided for you. And the important terminology is in the bold font. Practice slides usually come with this little yellow man. Our workshop is, as you know, it's advanced data visualization, which is quite an important topic in nowadays research and also day-to-day communications. So the goal of our workshop is that we want the audience to master the syntax and the grammar of the ggplot2. And we are also going to use a lot of online resources to generate the publication-ready figures. So this is for our benefits that we don't need to write everything from scratch. We can actually go to Google, go to the Stack Overflow, or even ask ChatGPT to provide some template. So based on the template, we can modify it to make the code suit our needs and then generate the figures in a relatively short time. So this is just to increase our productivity. And more importantly, I think instead of the skill set, we need to develop a mindset or even a taste for better data visualization. Because you know that for even the same set of data, we have multiple ways to visualize it. Then we probably need to decide, okay, what's the best way? What's the most efficient way? And how to visualize our data to make the information more compelling or more clear in some way. So basically, we want to develop a mindset or taste. So this is our agenda. This is a 3-day workshop. In the day one, we are going to cover some basics about the data visualization. Specifically, if you haven't worked with the ggplot2, or even you don't have the computing environment set up, we are going to address this issue. And more importantly, we are going to learn some data wrangling functions because, you know, sometimes the data must be ready, must be prepared well before we can visualize them. So this is actually an important part. We're going to talk about it, especially for today. And for the day 2, we are going to learn the very detailed components of ggplot2, specifically building a plot layer by layer. So we are going to explore different plot types like the scatter plot, the line plot, the histogram, heat map, etc., etc. So basically, those plots are really popular in our recent, in our current research. And also, we are going to learn more details about how to customize our plots. So getting more control over the plots. For example, if you want some kind of color, how to set it. If you want some kind of background, then how should we modify the ggplot2 object? On the day 3, we are going to talk about the examples and some useful packages. So besides the ggplot2, I want to mention there are a lot of extensions of ggplot2. Basically, if you are going to use them, you can actually save a lot of your time. You don't reinvent the wheels. You just use what's available in there. And we're also going to talk about some practical examples and more importantly, the principles for data visualization. So as you know that ggplot2 is a package in R. So our computing environment is predominantly will be the R. And specifically, we will use the RStudio as it provides a very convenient interface for us. to do a lot of like data science job. So here, ggplot2, actually I will talk it later, is a member of a tidyverse. So basically it's a whole toolkit for the data science. So if you are going to develop your skill set in the R data science environment, then this tidyverse is something you must, you probably will need to know in the future. So here I provided some of the reference. Specifically, this workshop is designed using this ggplot2 elegant graphics, and for data analysis, it's basically designed based on this book. And besides this book, there are also some very good books like R graphics cookbook, the R for data science, and specifically the foundation of data visualization. So I think those books is really helpful when I prepare the workshop materials. And basically, if you read all of them, you actually will be better than me. So I highly recommend it, especially for the ggplot2 elegant graphics, and also for the R for data science. So basically, those are really also very famous book in the R community. So talking about the author of this book, Hadley Wickham. So basically, he's the reason why we are here today. He's a really like famous people because he received the 2019 Corps President Award. So this award is the highest award in statistics, and usually they give it to some researchers, some professors who work on the theory, but in that year, we actually see the award is given to a guy who developed software. So this is kind of surprising at that time, but the award is given to him because of the reason that for the influential work in statistical computing, visualization, graphics, and data analysis. So basically here, we know that the visualization here is actually talking about the ggplot2. So that's he's the reason we are here today, but besides the ggplot2, he also developed a lot of other toolkits in the tidyverse. So if you are interested about the details, probably just Google his name, and he has a homepage, and you can see a lot of work it has done. So really remarkable person. So for our workshop, we are going to use R, and here I just listed the environment setup. If you haven't downloaded R for the R Studio, you can follow the steps in this slide. So first, I go to the official download web page. I just click this link, and then following the steps in the website, install R first, and then install the R Studio. For the install R, you will see this page based on your system, operating system of your personal computer. You can choose either of them, which is just fine. And after you following the steps, install the R and R Studio desktop, you probably will see the R Studio IDE open up, and then you can type in the copy the install packages, tidyverse, paste into your console, and then install this package. So I don't know like how many of you guys have already installed everything. If you haven't, then let me know. I can wait, and I can help you guys. So, okay, I think everybody is on the same page. All right, so for our day one, data visualization basics, we are going to learn the following topics. First, I will give a brief introduction about data visualization, about the ggplot2, and then we are going to learn the data wrangling functions. Specifically, I will assume you guys have some basic knowledge about R, but we are still diving into some details about the specific functions we are going to use. So these data wrangling functions will be pretty useful for your later work. So I think like when you are going to use the ggplot2 to make a lot of visualizations, you probably will come across some of these functions. And lastly, we were going to talk about the aesthetic mappings. So this is a 3-hour workshop, and I'm not going to talk for the continuous 3 hours. So it will kill you, trust me. So we are going to have a 10-minute break every 45 minutes. And for the next session, we will only have the 30 minutes as a workshop, and the rest of the time is about the practice and the Q&A. So a fun fact about the data visualization is that it's so natural, it's so so important in our daily life. So basically 90% of the information in our daily life is from the visual. And we are born to be able to see. We are not born to be able to read. So basically the visual are processed like 60,000 times than the text. So this is quite a dramatic difference. And usually people will always remember what they see. They probably have a poor memory about what they have read. So this is actually the reason why data visualization is so important, because it's so natural. It is so it brings you with a lot of information, and as a result, that's the reason why we should put a lot of focus on how to visualize it. So basically, if you have seen this sentence before, like the picture may be worse than 1,000 words. So here I just want to give a small example. For example, I asked ChatGPT to list the diameters of all the planets in the solar system. You can see, okay, ChatGPT is doing a good job, listed every planet in the clear format. But if I ask which planet is the biggest one, which is the smallest one, but you still need to do a lot of like back and forth searching, reading to figure out the answer. But if I give you just the image, you can directly tell, okay, which one is the biggest one, which one is the smallest one, and which is the second biggest one. So basically, this is a very intuitive and a vivid visualization way to deliver information. But sometimes this kind of visualization can also be imprecise, or sometimes it can be misleading. So anyone found any kind of like inaccuracy about the figure here? Any idea? Oh, okay. Yeah. Yeah, that's exactly, yeah. So basically, we can tell, okay, the relative size between different planets, but we cannot. It's not possible that these planets is so close to each other. This is against the physics law, right? So basically, we should be really careful. Sometimes we need to really think about how to visualize the data in some way. So this is actually like a picture maybe worse than 1,000 words. It's actually said by a famous computer scientist called the Dijkstra. So basically, this computer scientist developed the algorithm that tries to find the shortest path between two nodes in a network. So if you so this sentence first appears in his draft about first exploration about effective reasoning in 1996. And actually there is another sentence following called a formula is worse than 1,000 pictures. So I think this is this echoes my previous point that when you visualize data, you need to really consider how to make it for the first step be intuitive, and for the second be precise, be accurate. So a formula is worth 1,000 pictures. Probably this can be illustrated by the Newton's law of gravitation. So basically, if I don't give you any details about the formula, you see this picture, you will see, okay, the force is decreased as the distance increase, but it's not clear whether the speed of decreasing is in the order of a quadratic term or is in the order of the exponential term. So basically, a formula could better help us to make this point more clear. For example, in the Newton's law, we know it's decreased in the quadratic form. So basically, this when we add this information to the plot, we probably will get a better understanding about the relationship between force and distance. So we are going to later, maybe tomorrow or the day after tomorrow, we are going to talk about how to add some kind of equations to our plots, etc. So actually, here comes another question. So picture may be worse than 1,000 words, and then a formula is worse than 1,000 pictures. So the question follows that what worse than 1,000 formulas? Any idea? Yeah, I honestly, I don't have the answer right now. So if you figure out, please do let me know. So the role of data validation in science is really important. First of all, there are several typical steps in the scientific work involved in data analysis. So, for example, if you are a biologist, if you are a computational biologist, you do a lot of experiment either by in silico simulation or you generating data. So basically, after you get the data, you need to process them. So data validation can be really helpful. For example, you want to do some quality control to remove some outliers. Data validation can be really helpful. And when you try to present your results, you need to generate figures, tables. So basically, data validation is really involved in all the pre-processing and the downstream analysis. So as a scientist, we actually rely on those data validation tools to explore the data and also to explain the results to our reader. So this is like two different main goal of the data validation. So if you go to some kind of high profile journal, for example, here I just listed one paper published in I think in November last year, several months ago. So in just one single paper, they use a lot of data validation tricks. For example, using the box plot or violin plot, even the histogram to visualize the distribution between two groups, and then using the bar plot to show the compositional changes, using the line plot to show the how the genomic distance is related to some kind of signal, and using the scatter plot to show the relationship between two variables, using the heat map to show the whole landscape of some kind of features. So basically, if you are going to, so basically in tomorrow's workshop, we are going to learn each of them one by one. And for today, I really want to emphasize like all of those tasks can be finished by ggplot2. So ggplot2 is actually a really powerful tool to finish those data visualization tasks. So ggplot2 is actually a core member of tidyverse. So if you read the data science book of R, you probably see this figure before that a typical data science project involves import the data, and then you do a lot of data cleansing, and you transform the data to build the models, visualize the results, and form a kind of a loop to feedback to whether you need to further clean your data, and then build another model, etc. And afterwards, you will communicate the results to the potential readers. So in this section, one of the core sections is visualized. So ggplot2 is actually designed for the whole visualization purpose. And as I said, like before that, tidyverse is a collection of R package. So basically everything listed here with R table is actually just a member of a tidyverse. So it's a whole toolkit for the data scientists in R. For the idea behind ggplot2 visualization, you can think ggplot2 is a function. So functions is going to map something, transform something to another thing. So here, the input is actually just the data, and usually it's in the data frame format. It's tabular data, and the output is just a figure or something. And then we want to find some kind of mapping between them. So basically here, just as a scatter plot, as an example, that we defined what is the x-axis, what is the y-axis, and then for the aesthetic attributes, for example, the color, or even the geometry, we want something to represent it. So basically here we are mapping the HWY, which is the highway, to x-axis, displacement to the y-axis, and the drive to the color. So basically what ggplot2 does is first take your data and define a mapping, and then render your plots based on the geometry you choose. So here, the geometry is just a circle, it's a dot. But in tomorrow's workshop, we will learn the details. But today, I really want to give a big picture about what ggplot2 is doing. So as I said, there are several key components of a ggplot2 object. One is the data, the source of your plots, and then the aesthetic mapping that you try to map your variables in your data frame to the variables in the picture. For example, x and y axis is the position variables, and the color, even the shape, is the attribute, the aesthetic variables. So basically, you want to define a mapping between the data variables to the visual properties. And then there is at least one layer that is describing how to render the observations. So here we try to plot them just using a single dots. So this can be a layer of geometry, which takes the original data, and then have the geometry as the basic elements. So to create a ggplot object, we can just call this function ggplot, and then also first you need to library load the package, and then after that you can call this ggplot with specify your data and specify the mappings, aesthetic mappings. So the data is a data set user to plot. The mapping is a list of aesthetic mappings we are going to use, and there are also some other arguments. So here the data and the mappings specifications are optional. You don't really need to type in everything. For example, you can just put your data frame name as the first variable, and then put the AES and your mapping as the second variable. So you don't really need to specify data equals mapping equals specifications. So as long as you pass them in the right order into the function, that would be fine. So usually after you call this ggplot function, they usually followed by a plus sign and adding the additional components. Sometimes we call it layers to the plot. So as I said before, that layer can be the geometry, like how you want to represent your data. So this ggplot, as we said, as we saw here, is that we have the data, we have the mapping, and also we have the layers. So actually, this idea is originated from the grammar of graphics, developed by a talented computer scientist, Leland Wilkinson. So in his book, 1999, he actually proposed a different layer grammar of graphics. So in the bottom layer is the data, and following the aesthetic mapping, define how we want to map the variables to the visual properties, and then we define the geometries, how we want to represent the data. And sometimes we have the very huge data set. We have different aspects of the data. We want to do some faceting. So lastly, sometimes we want to do some kind of statistical transformation. For example, calculate the density, the 2D density, or even the contour plot, etc. We want to do some statistical transformation and the summarization. So next layer is the coordinates. Defines how we want to present the data, which coordinate system we want to use. And then lastly is the data irrelevant layer that we want to modify the theme to change the color or tries to adjust the borderline, etc. So basically, this is a non-data relevant data irrelevant layer. So here is a specific explanation about each layer, but the idea is that we can actually decompose the whole graphics into these several components. And for each component, we will talk one by one, and we will name one by one in today and tomorrow's lecture. So basically, if we realize that we can actually decompose the whole graphic into layers, we can actually build the plots layer by layer. So here I just tried to plot using the MPG dataset. So first we define the aesthetic mapping, tries to map the highway to the X, displacement to the Y. And here, because we don't use any geometry to render the plot, what we get will only be the X and the Y axis. There is no data plotted on them, although the data is there, but we didn't render it. So if we run it, then we will get this plot. And the next, we can actually add the geometry layer. For example, we use the geometry point to show the data point on the plot. And actually, we can define another aesthetic mapping within the geometry layer to add a color based on another variable. So basically, what we are doing here is just try to map the color with our data variables here. So next, we can add a statistical summarization. For example, we use a geometry smooth and use the method as a linear model to fit a regression line. So basically, you don't really need to run your own like LM function to get what is the beta, what is the intercept, etc. So basically, it will automatically do everything for you. So it's really powerful. So lastly, you can slightly adjust the theme. As we said, theme is a non-data link. So basically, you want to put some kind of labels into your figure, like the title, subtitle. You want to adjust the background color, etc. So those are what themes. So basically, here you can actually see that we use the plus sign build on the base plot. Use a plus sign to add different components, and each one by one, you will see different results. So this actually gives us a lot of flexibility. For example, you want to change a single component, you simply change just a single line, and then you can iteratively adjust your plot. So basically, to align your desire or to align with your expectation. This gives us a lot of a lot of room for the customization. So I think probably we can do some practice. Just try to run this example. So if you copy this line. So if you directly copy the gate clone line, And from your studio, so first, if you haven't installed this package, you can install it just following the instruction on the slides. Because I already have it installed, so I can just directly library load them. And if you go to the terminal and paste the git command, I think I got an error because I already have one folder with the same name. And remove this folder first and the git clone again. So after you finish the git clone, you will see this folder, and go back to the RStudio interface. You can actually see what's inside the folder, and you can take a look at the Markdown file. So here, I prepared some kind of guidance for how to use the R Markdown if you haven't used it before. Then here are some kind of simple tricks to use the R Markdown. For example, if you want to insert a code chunk, if you are on a Mac, you can press command line and Alt and or Control. Command line Shift Control. So basically, it will insert a code chunk for you. Alternatively, you can also press your own ticks and also the brackets and R. So basically, you will manually create the code chunk. But here I just listed some kind of hotkeys or shortcuts you can use. And also here I listed some kind of cheat sheet. If you don't really know R Markdown really well, you can check them because R Markdown is not the focus of our workshop. We are not going to put a lot of emphasis on them. But I think it's really useful. So probably you can check one of them and then see how to use R Markdown in the RStudio interface. So for the environment setup, if you haven't done so, you can, if you haven't installed the Tidyverse package, you can install it. So basically what it does is that try to check if Tidyverse is installed or not. If not, then install this package and then load this library. So after that, you can try to run the load the data MPG into your own interface, and then head MPG here is just to try to check the top several number lines. You can see how many of the variables are there and whether they are the string variable, like character variables, or just a double variable, like a continuous variable. So here, as we did in this, in the workshop slides, we first create a ggplot object based on the MPG data. So basically here, you don't need to specify the data equals. So this is just optional, but if you want to type in that, that's also doable. And also specify what's the aesthetic mappings. So if we run this line, we will see that we define the X and Y axis, but we didn't render any data points on that. So actually in the created ggplot ggplot object base, you can actually using the $sign to access what's inside the list. So basically here base isn't just a list, although it's a ggplot, but you can access the components with it. So for example, if you want to check the data, simply press enter key and you will see what's the data look like within the base object. And also there are a lot of other components, layers, and the scales mappings. So basically those are the ones we are going to learn tomorrow. So for the next part is that we can use the geometry point to render the data points into our plot. And if we want to color it, we simply map a variable to the color using the aesthetic mapping. So next, we simply follow what we did in the slides, add another statistical transformation layer, try to find the linear regression for the current data set, and adjust the same using same minimal, and then add the GG title to the title and the subtitle using the GG title to the plot. So this is the basically the repetition of what we did in the slides. So basically, I think you can try to run it on your site. And probably we can take a small break here, a mini break, and then when we come back, we are going to learn about the data wrangling functions. So as you guys seen before, that we have so many layers of ggplot2 object. So the very basic layer is the data, and basically today we are going to just introduce the bottom two, like data and aesthetic mapping. So for the data, I think it's still quite important because most of the time, for example, if you are working on a data science project, maybe 90% of time you are spending with just a data cleaning, data manipulation, transformation, etc., etc. So basically, data cleaning part is I think is very essential for the visualization part, especially once you have the right data in the right format, aggregated in the right way. Usually, the right visualization is obvious. So I think the data cleaning is really important, especially when you are dealing with the real world data, because right now, especially in this workshop, the data we work on is really clean. You don't have a lot of like missing values. You don't have very strange outliers. So it's basically everything is very clean, very tiny. In the real world data, if you are working on your own projects, probably you will face a lot of issues. For example, you have tens of millions of records, which makes the data really big, and loading into your memory probably will take forever. And also you will see a lot of like format issues of the real data. So basically here, today we are going to learn some functions to help you deal with it. But again, like I said, the functions we talk about today is just the tip of the iceberg. If you want to be an expert in this field, probably you should read the R for Data Science, that book. It will have a more detailed tutorial on how to do the data manipulations. So for R, we first talk about the variables. If you know any programming language before, you know that the variable is just a container that tries to store some values for you. For example, if you have just one single variable, it's just storing one value. And then if you have a array or a string, then it might store a lot of values. So for the variables, we actually can classify them into two types. One is a categorical variable, that it will take the discrete value. So for example, the gender, like male, female, it's just a discrete variable. And also the sometimes we call it as a nominal variable because we refer them without a order. Like for example, here X is apple, banana, etc. We don't see banana is bigger than apple, etc. So basically, these nominal variables is without an order. And there are also some ordinary variables with an order because sometimes we grade something to be low, medium, high. So implicitly, we are referring high is greater than medium, greater than low. So we actually have an order within the discrete values. So this is called the ordinal variable. And besides the categorical variable, we also have the continuous variable, which takes a continuous value within a range. See here, it's just like a continuous variable in the either in the like either below 0 or above 0. So talking about the variable types, there is one important concept called the factors in R, which takes the categorical variable and store the data in levels. So the levels is what we defined. For example, if we specify the levels to be low, medium, and high, so basically we are actually giving low with a value 1, medium with value 2, etc., and so on. So the levels is just like an integer level. We are assigning to each of the discrete values. We can use the function factor to convert the categorical variable into the factors. So this is particularly useful in plotting. Specifically, for example, you want to plot a bar plot, and you want the bars to be ordered in some way. So this is actually the tricks we are going to use. You can assign the factors to each of the bar, and then you arrange them, for example, from the in the decreasing order or in the ascending order. So basically, this is the tricks we can use how to arrange the bars. So here, I simply give you 2 exercises. Probably you can try on your end, which is also in the R Markdown file. You can try these 2 lines. Simply run these 2 lines and see what will happen. Yeah, maybe this is kind of simple. Maybe I can just show the results. So basically, after you run the y1 equals factor y and y2 equals factor y with the specified levels, you will see that y1 and y2, the levels is not the same. So basically, y2 will be the levels you specified from low, medium to high. But y1, you can clearly see that the levels is ordered, it's ranked by the alphabetical levels, like H is head of L and head of M. So basically, if you don't specify the levels yourself, this is the default. They were going to rank the factor, the categorical variables according to the alphabetical order. So talking about the variables, we also talk about the data frame, which is just a tabular data. You can also think it as the aggregation of the variables. So specifically for each of the column, we call it as the variables. For each of the row, we call it as observations. And within the data, like each cell, we take the numbers or values them. We refer them as the values. So actually, you can use a data.frame to create a data frame. Here, I just listed a very simple example. Try to assign the levels and also the label, low, medium, high. And after you run this, you will get a very simple data frame. For example, if I run here, you will see the DF. Which X and Y is our variables, and 1, 2, 3 is our observations. So it's just like an Excel table you deal with when you use the Microsoft Excel. So here I listed several functions for the data wrangling functions. First, we are going to learn the manipulate observations, which is the manipulate the rows function, filter, arrange, and bind the rows. And also we will learn the operations on the variables or on the columns as the select, mutate, or the different join functions. And sometimes we want to reshape the data from the known to wide or from wide to known. We are going to learn the pivot longer, pivot wider. And sometimes we want to group our data into according to some variables and then summarize it. For example, what's the mean value, what's the variance, etc. So we can actually use the group by and summarize function to do that. So here I also provide the cheat sheet for you to check. So basically, you can see there are a lot of more functions besides the ones I talked about here. There's so many others. You can actually try each of them. They provide some examples. You can try to run it and see what's the output look like. So basically, the cheat sheet is also very useful. You don't have to memorize everything. Every time you want to look for some kind of function usage, you can just go to Google and check the cheat sheet. So long as you have network, then you don't need to memorize anything here. So manipulate observation, the first thing we learn is the filter function that we try to keep the rows that satisfies certain conditions. So the first argument of filter is a data frame, and the second as subsequent arguments is logical vectors. So the logical vectors can be something like, for example, comparison. So if you, for example, if you have a variable and you want to compare the variable whether it equals to some value or whether it's greater than some value, etc. So you can actually using the comparison operators listed here to create the filtering criterion. Or sometimes you want to do some more complicated operations using the logical operators. So you can actually combine several conditions, criterions together using the and or not or something else to do the compound filtering. So later we will show some examples, but let me finish the rest of two functions first. So besides the filtering, which is tries to exclude some of the rows that we don't want and only keep the rows that satisfy certain conditions. And there is another function called arrange that tries to order the observations based on some variables. So for example, here as is shown here, that we have some values, variables for each of the observation, and then we rank it from the smallest to highest. If we denote the smallest to be the lightest, and the highest at the darkest. So again, the first argument is also a data frame, and the second and the subsequent argument are the variables of or functions of variables. So if you put the two variables first, into the range, variable 1, variable 2, and so basically it will arrange you based on variable 1 first, and then if there are ties of the variable 1, they will use the variable 2 to do the ranking. So it also have an argument the by group. So basically, if it's true, then it will first sort by the grouping variables. Grouping variables we will talk about later using the group by. But here it actually can support for the group range. So the default sorting order is ascending. That means smallest to highest. So if you want to do the opposite way, the reverse way, you can use the decrease function to the variables and then after you apply the range, then it will sort the variable in the descending order. So besides the filtering range, and then we have these bind rows that we can bind any number of data frames by row. So basically, this will do similar things as R bind, like a row bind in the base R function, but it's more convenient to use because right now here, you can actually input a lot of data frames into just one single function, like a data frame 1, data frame 2, and data frame 3. Just input everything into the as the argument of the bind rows function, and then it will finally output a final data frame for you. So compared to the R bind function, this one is more convenient to use. And if the bind rows actually will work by checking the bind the columns based on the columns names. So if the names are not matched together, then it will detect some kind of missing values. So it will fill in the missing columns with an NA. So probably we can do a small exercise in our markdown file. Basically for the manipulate observation, we have the filtering. So here, as we talked about in the slides, filter, the first argument is the data frame, and the second argument is a criterion. So here we use the, we can check the MPG data first. We have a model, it takes quite a lot of values. So the first data frame, the first code we run is that tries to keep the observations that have the A4 in the model. So basically, if we run it, it will only keep the first 7 rows as a final result. So if, and the second one is that we use a compound condition that we satisfy the model master equals to A4 and the CYL, this variable master equals to 4. So if we run it, we can actually see for the first data frame, first function's output, it will return a data frame. And we can see in the models column, it's more A4. This is because we specify this model master equals to A4. And for the second one, besides the model equals to A4, the CYL, this variable must equal to 4. So basically, this is a very useful function when you do data cleansing, just using the filter to exclude the rows you don't want and keep the desired ones. So for the arrange function, the first argument is also the data frame, and the second was subsequent argument. It's a variable or a variable that with a function. For example, using the descending function. So here after we run it, we can see that the arrange for the first data frame, it will arrange our highway observations from small all the way to the big ones, all the way to maybe 240s. And if we put a decreasing function before the variable, then it will arrange rank the observation based on the descending order of highway. So this is a small, still very useful function. Tries to reorder your data frame. So here is another function, the bind rows, tries to merge two data frame by rows. So here, for example, I already do the filtering and keep it. The data frame 1 must be manufacturer of Audi, and data frame 2 must be the manufacturer of Ford. So basically, after we do the filtering, we want to combine them together by simply just concatenate them. So we can put them into the bind rows, this will give us the final results that the manufacturer either be Audi or the Ford. So basically, this is also how we can split the original data into small pieces and then combine them into into a finalized version of data frame. So here I prepared 3 small exercises for you guys. You can try to run it on your own, and maybe I will give 3 minutes for the exercise. Okay, I guess I can just show about the results. So first of all, we want to extract the top 10 of T. So basically we can do the, for example, 1 equals the filter. We can actually arrange the MPG based on the descending order. 1. Yeah, so I think another small trick I can provide with you guys is the Google the GitHub Copilot. So basically, you can see that when I type in something, it will give you some hints, and usually it gives you the correct answer. So basically, I didn't type in too many things, just type in the arrange, and then following it will just give the 1 to 10 to get the top 10 results. So we can just check it. So basically let me see the descending order CT, yeah, from the descending order, and then take the top 10. So this is how we actually do the first exercise. And for the second one, let me still show you the trick. So basically, it's a Copilot plugin for the RStudio, and it's really helpful. Can really shorten your programming time. So we can create the exercise 2. So first, we want to do a filtering of the MPG, so that all the that the manufacturer either in Audi or Ford, and filter the CT1. So after that, we want to arrange the results in the descending order. So basically, this is simply we do a filtering first, and then we do a ordering later. So after that, we can check the results and see if the result is expected. So first, the CT is ranked by the descending order. This is correct, and also the manufacturer is either the is only the Audi, and CTY is greater than 80. So basically, this is how we solve the second problem. And the third one is that we want to bind those df and df2. So if we check the results, we will see there are many NA values in the resulting data frame. This is simply because for the df, it has 2 rows, x and y, and for the df2, it has 2 rows, two columns, x and y0. So y and y0, because they are not at the same name. So basically, the binder rows will think these 2 columns are two different variables. So they are going to fill the missing values with NA. So this is exactly the reason why we see why there are so many NAs here. So if you want to if we want to still want to combine x and y with the x and the y0, regardless of y and y0, so just one simple solution is that you can rename the data frame to be the same name. For example, here you can rename it as X and Y. Actually, I need to put it into college. Then find the rows. So now the problem will no longer exist because the binder rows will first check the variable name and then decide how to bind the data. So if you already change the name to be the same, you will see there will be no missing values anymore. So this is the binder rows manipulate the observations. There are also some other functions to manipulate the variables, which is the columns. The first one is select. So this is very similar to the filter, but what we do here is that we operate on the columns, on the variables. So select will keep or drop variables using the names or types. And the first argument is the data frame, and the second and subsequent are the encoded expression separated by the comma. So basically, for example, if you have multiple variables you want to select, you want to keep, just as shown here, you can actually use the or of and then put in the vector of variable names. And also, if you want to select the columns that starts with a certain symbol or ends with a certain symbol, you can use the starts with and the ends with. And if you want to put your own more complicated functions, you can use the where function. And also, besides that, you can use the operators, logical operators, and the or, and also the concatenation to combine the selections. For the variable, if you want to create a new variables, you can use the mutate to create a new variables. So basically, it will create a new columns for you, either based on the current data or you will supply the data. So the second and subsequent arguments are the name value pairs. Later we will show what is the name value pairs in the mutate function. So the values can be vector of length 1. In this case, for example, if you want to include a new column in the data frame, for example, you want to include the intercept to be or once, simply just mutate intercept equals 1. So here the vector of length 1 will be recycled to the full length of the data frame. And also the vector of the same length can be the same length as the whole data frame or the current groups for the group data. And if you want to drop some kind of columns, you can specify the column, mutate the column name or the variable name to be null. So this will remove the variable from the current data frame. So besides the manipulate, the select, and also mutate, which one is the select from, and then the other one is try to create a new column, new variable. We also have some other functions that tries to work on 2 different data frames. So for example, for the inner join, which tries to consider the common observations. The for join tries to consider all the observations. The left join only considers the observations from the left data frame, which is X here. And the right join is the consider the observations in the right data frame, which is Y. So to put it into more details, it's that we simply, for the inner join, we only consider the overlapped observations, for example, X and Y, and you specify variables to be as an index variable, which is you only use a by argument. You will see that the output will only have the overlapped observations. And for the for join, it tries to consider all of the observations it will not exclude any samples, and the missing values usually will be filled in with the NA value. So the left join usually is only consider the observations in the left panel, left data frame, and similarly for the right join, it will only have the observations in the right data frame. So here is the simple summary for how to use the left join, right join, inner join, and the full join. So basically, you input 2 data frames and then specify which of the columns or which of the variables to be aligned. For example, here specify to be x1. It will use x1 as the index and then try to adjust the other data frames. So I think we can also work on some practice to gain more proficiency about these 3 functions we work. So for the manipulated variables, the first thing we learn is to select the first argument is a data frame, and then you specify the variable names. So after you run it, you will see that although our original data frame has 11 variables, but the resulting data frame only contains the variables you specified, like manufacturer, model, and the displacement. And then for the next one, it's the highway, city, etc. And if you want to create a new variable based on the existing variables, you can simply just mutate the data frame, give it a name value pair. The name is a ratio, and the value is a ratio between highway and the city. So simply you put it as assign the value, assign the new value into the lane. So basically, this is the lane value pair we talked about in the slides. So after you run that, you will see the there is a ratio calculated, the ratio column exists. Maybe I can give you another 3 minutes to try the different join on the MPGDF3 and 4, and see if you have any issues about running them. So maybe I just do a small demo to the existing problems. So let me see what's inside the DF3 and the DF4. So manufacturer model year, displacement. So basically, if we want to do an inner join, MPGDF3 and then PGDF4, so we can actually specify a vector to the by variable, to the by argument, manufacturer, and the model, and the year. So this will give you the results. Right. And specifically, you can also type in the for join, after join, which is pretty much similar. So next, I want to mention another very useful trick for the manipulating the data. That is sometimes we want to pivot the data from long format to wide format, or vice versa. So basically here we can see that the wide format is that we have X and Y and Z. Basically it's our variable. Each of them have the values. So basically we can convert it into the K and the value pair. So basically here we will have a known format of the values. So on the other hand, we can also create the recreate the wide format using the K here, just extract the unique values into the variable names and refill the values into the cells. So this pivot wider is helping us doing this. So the pivot longer, we can pass the data frame as the first argument, and then the second one is the columns we want to convert, and specify the names to either for example to the K and values to the val. So basically this is the usage of this function. And if we want to convert from the known format to the wide format, we can simply specify the names from a column and the value from another column, so that we can reverse this process from known to wide. So here is actually a small demo of how we do the conversion. That simply we specify the variable names as a K, and what the other values as what the other cells as the values, and then just assign the values into a new data frame. So this reshaping is kind of useful in plotting some of the scatter plots. For example, you want to do some kind of group scatter plot, and you don't need to specify like create n plots. Each of them specify a variable with another variable. Simply, you can just convert the wide format into a known format, and using the facet to split the data into different panels, and then make the plot work in once. Instead of using a for loop, that way is much more efficient. So after the reshaping, there is another two useful functions, like a group and a summarize. So consider, for example, if you have two groups of data, and then you want to plot where is the median, where is the mean, and what's the standard deviation per each group. So basically, this group and the summarize function is helping you doing that. So the group by function is that you define a grouping variables, specifically split the data into the different groups according to this variable. And then summarize is that, for example, if this 3 belongs to one group, then you calculate the statistics, for example, the mean, the variance, the quantile, etc. Simply just using the observation from one group and using the observation from another group to calculate another summary. So basically here it's the listed functions you can use instead of mean, median, SD. You can also calculate the minimum value, maximum value, etc. So when you try to get a group summary, the group by and summarize function is really useful. So after you group a data frame and you want to revert to the original data frame, you can simply use the ungroup. So this will just remove the grouping and returns to the original data frames. So besides this two function, I also want to introduce a very useful usage of the pipe, the chain, tries to chain different functions together. So basically here, I listed 3 different versions of code that tries to finish the same thing. So based on your own taste, which one do you think is the most elegant one? Like any guess, any answer? The left one or the right one? Yeah. So yeah, this one is the most elegant. Actually, this is the recommended way in type diverse usage, that you can actually just write it using the write it, and each of the steps is a processing step, and you just chain them using this pipe symbol. So the good advantage for this way is that you can actually have a really clear view of which step is responsible for what operations, and usually you can just, for example, copy certain steps to do some sanity check whether it's doing the right job for you or not. And besides the kernel structure, it also have a very good advantage in maintenance. So, for example, sometimes you want to do this same thing, like same pipeline, into another set of data. So what you need to do is just try to change the input data, and then all the following code, you don't need to change them. So basically, it can be easily transferred to other data processing steps. So this one is what we recommended in the Tidyverse. So this pipe command actually works by taking the object from the left-hand side. For example, here it's a diamonds left-hand side, and use it as the first argument to the function of the right-hand side. So as you remember that previously, all the functions we talked about, the first argument is always a data frame. So if you use it in the pipe command, you can just omit that first argument and just simply put the following arguments. So for example, here, if the original function is the fxy, if you want to write in the pipe format, then you can write it as the pipe, and the fy. So remember that the first argument is already omit. So here is a small exercise. Maybe I can give you guys 30 seconds to write it. So to solve this type question, let me see. So again, this is a nested function that we usually try to solve what's the innermost nested function, which is the fx. So basically, we can actually, as a previous example, that we can write the fx as this way, the pipe way, and then the following results will be passed on to this g function. So basically, we will just put a gz behind the pipe, and then this one is equivalent to the nested function here. So I think it's very intuitive. So maybe we can do another set of exercise by checking the reshape the data. So basically here we have several columns of data, data frame 4. And here we want to convert the last 2 columns into the known format. So basically we specify the mpgdf4. The first argument is the data frame, and then the columns is the variables that we want to convert it into the known format. And we specify the names to type and the values to male Paganin. So after we run that, after we run this whole function, we assign the output into a new data frame, and then see what's the output of the new data frame. So basically, we can see that compared to the previous wide format, still manufacturer model and year is still persist, and we convert the highway and the city into this type and the male Paganin. So this is a very useful function. Convert known to wide, convert wide to known. So maybe I can give you 1 minute to try on this exercise, then how to reverse this known format into the wide format. Together. So if you work on this exercise and just using this line of code, for example, here, mpgdf4 names from type, values from male Paganin, and you probably see some warnings saying that the values from male Paganin are not uniquely identified, output will contain. So basically, it will not give the desired output as you want. So why was that? This is actually because, yeah, for known, that our data frame contains some kind of duplicates. So for example, for the first row and for the third row, they are essentially the same thing. So if you try to construct try to pivot to the wider part, it actually don't know so basically those two lines will be exactly the same, and then they don't really know how to convert to the original form. So to solve this problem is that we can try to create a variable that do some deduplication, like try to give it a unique identifier, so the function will work without any warning. So to do this, we can try, for example, here I just use the pipe function because it's much more simpler. So we can actually try to do group by first type, and then within each of the type, we can assign. Yeah, maybe we can do some yeah, just a type. We can try to create a new variable, which is like the row number n equals to row number. So this way, after we group and give it a row number, it will give this n row number will be a unique identifier for each of the rows. So after that, we can try to run the pivot wider from here. Hopefully it will work. So here, it will give the results as suggested. So in this way, it will no longer give any warnings. It will just return the exact data frame for us. So because this one will still contain this n variable, so we can actually select -n to drop it. So this way we will revise the code into to make the data table to the original form. So, but the idea here is that the original code doesn't really work because there are duplications. The current one that tries to assign each row with a unique identifier will make it work. So this is the pivot wider and longer function. And here is a group and summarize. Here, for example, we want to group by the year and the manufacturer. And then after the grouping, we can compute the mean, the average of highway and average of city. So after we run the summarize, essentially we will get a value per group. So we can actually see it that for each of the year and the manufacturer, we will have the average of highway and the city. So this is really convenient. You don't need to split the data by your own self, like tries to find the combination between year and the manufacturer, and then using a for loop to subset the data and calculate the mean and the city average by yourself. You simply just group it, so it automatically partition the data based on these two variables, and then you summarize to be the mean and to be the mean of the highway and the city, simply using the summarize function. Just name it as a name and a value pair. So yeah, for this one, this one. So maybe later I can go to a place and see what's your error, what error you got. So for the later part, is that we, for example, for the group and the summarize, we have the we write it into this form that we still try to assign the output of each function to a new data frame. And then later we can actually replace the whole thing using the pipe. So basically we can rewrite the whole part from here, that MPG pipe into the group by, and then pipe into the summarize. So essentially this will give the same results as we did before, but it with much more cleaner code. So after running it, we see for each of the year and the manufacturer, we have a mean value of the highway and the city. So probably I can give you 1 minute, maybe 2, to work on this exercise and try if you understand it. So this one, I think it's rather a little bit simple. So basically, you can try to first group by each year and then summarize to get the smallest value for city. So basically, for example, we can create a new data frame. Exercise equals, and using the pipe that you group by the year, and then summarize city name plus city. But this one will only give you the smallest value. It will not give you the whole the whole data frame. So what you can do is actually just using the inner join to join this MPGX EX3 with MPG, like using an inner join to try to by using the year and the city mean, it will give you the whole record for the whole data frame. So I'm not going to write the full function of it, but it's pretty straightforward. Okay, so I think for the last bit of time, we can talk a little bit about aesthetic mapping, because we spend quite a lot of time in doing the data processing, data cleansing, and some of them are pretty useful. And so after that, we are ready to wrap our data into the plotting functions. So the very first thing we need to do is to set the aesthetic mapping. So aesthetics is if you just watch at any plot, you will see the position X and Y. So this is the attribute of aesthetics, and also the shape of the dot and the size of the dot and different color, line width and the line type. So all of them are the attributes. One of them can be specified in the aesthetic mapping. So to set the mappings, you simply just using the AES, which is just the short for the aesthetics, describe how the variables are mapped to the visual properties. So it can take the aesthetic value pairs. Basically here you can, as we do it before, like the X equals displacement, Y equals the highway, and the color, map the color to the class. And besides that, we can also specify other aesthetics for different types of plot. For example, if you plot a scatter plot, you can specify the fill to decide what colors to fill in the dot. And for the alpha, like you can set the transparency. And for the line type, if you plot a line, you can specify whether it's a solid line, a dashed line. And also for the shape of geometry, like you can specify whether it's a triangular or square or the any other polygon types. So basically here you can check the different available options using this line of code vintage, ggplot2 specs, and for the line type, here it's like the available options you can choose. For the shape, it has a different number, like each of the number denotes a symbol, like a geometry type, geometry shape you can use. So besides this direct setting, aesthetic mapping also support some kind of simple transformations. For example, if you want to perform the log transformation, you can simply specify it like the transformation function with your variable name, directly supply it into the aesthetic mappings. And also you can try to add override or remove the previously set mappings. For example, if you specify the mapping in the ggplot function directly, and then later when you add another layer, like a geometry, so if you don't specify the aesthetic mapping, so it will by default will use the original setting. And in this layer, you can actually add different mappings or override. Like for example, the previous color is attribute class, and you can make it to some other variables, or even remove the mappings by simply changing, like map the variables to a null value. So besides the aesthetic mapping, there is also another trick to do the aesthetic setting. So mapping is always you want to map a variable to, for example, to another variable. So this is called mapping. But setting is that you can actually set the variable to be a constant. So the difference between aesthetic mapping and the setting is that in the aesthetic mapping, you always put the variable and also the another variable or even a constant within the AES function. If for a setting, it's usually like it's outside the AES function. So whenever you use the AES function, it's a mapping. If you don't want to set the mapping, then just put it outside. So besides the aesthetic mapping and the settings, there are also some other things you should consider when you use the aesthetic mappings. For example, you based on the variable types of your data, you can choose the visual aesthetics more wisely. For example, the color and the shape works pretty well for the categorical variables like yellow and blue and red. So there are different types. So you can probably map the categorical variables to the color and the shape. But if you are working with the continuous variables, then probably the size will be a better choice. Because sometimes we are really hard to distinguish the lightness of the color, but we are really good at distinguishing the different size of cycles. Just showing as an example here, the left panel is that we map the continuous variable to the size. And we can clearly see that probably the left-hand side cycle is twice of the size in area of the right-hand side. But for the right part, we cannot tell. We only know that the left-hand side cycle has a darker color than the right-hand cycle, but we don't know like what's the ratio. Like it's 3 times, 5 times more possibility, because our human eyes are not really good at distinguish the lightness or darkness, the ratio between them. And also, don't make the plot too busy. Usually, for example, sometimes we want to map the aesthetic mapping to a single variable, but we map it to the color and to the shape, to the size. So basically, this way, you are actually dilute the signal. You are making it too busy, and you are making the plots to be like more easy to distract people, so they don't really get the message. So this is just a simple rule that less is more. Only use the aesthetics when it's necessary, when it's really helpful. So I think that's for the slides. So we can go back to our tutorial and work on our final part of the exercise. So here, let's go to the aesthetic mapping section that we construct the base plot, that we simply specify the data and the mappings. And then we specify, we want to use the scatter plot to show them. So after we run it, we see that it will have the displacement as x-axis highway at the y-axis and colored by different class. So as we said, you can actually pass the aesthetic mapping other layers, like a geometry layer, to add the layer or override the layer or remove the previous mappings. So if we run it, for example, here for the first plot, we add another variable like a shape, another variable to the map another variable to shape. So basically we can see that drive class, they have different color and then different shapes. But again, like as I said before, that right now you can really not tell, okay, what's a clear message here. You will only see so many fancy dots here, but you don't really know which drive is pop up and which class has a higher highway mileage, etc. So basically, the ggplot is not preferred especially when the message is weak. And also, you can try to override the previous mapping by specifying another variable to the previous settings. For example, previously you map the color, you map the class with a map color to the class. Right now, you change the color to the drive. So again, like when we do the mappings, we see that only the 4 different drives. Again, the title of the legend is not changed, it hasn't been changed. Later we will talk about how to change it. But right now, like we can see the color is defined by the variable of drive. So the next one is that we can remove the previous mapping by simply map the color to a null value. So the null value will just set it to null, so it will not be colored by the previous set class. And here is an example that we show we can actually do some simple transformation within the aesthetic mapping. If we run this code, these 2 lines of code only have difference between in the x log displacement or the x original displacement. So basically, we can see that the plot is essentially quite similar. Only the difference is the x-axis is changed from the displacement to the log displacement. So the rest is the same. So another interesting part about the aesthetic mapping and setting, if you are confused about the slides, maybe these 2 lines of code can solve some questions. So first of all, if we set the color to be a constant and put it inside the aesthetic mapping function, although we set it to be the blue, but somehow the color is still showing as a red. The reason is that when we set a constant to a variable inside the AES function, it actually creates a new variable inside the data frame, and using that new variable as the coloring variable. So basically, that blue is the ggplot function will only treat that blue as a string. So basically, it will not recognize it's a color, but only a string. So this is the reason why we see although we specify the blue in the AES, but it shows as a red. So if you try to move this part out of the AES function, this will become the aesthetic setting. So basically, the color will still be the specified blue color. Like the only difference is that whether we put this variable inside the AES function or outside the AES function. So one is the above one is the mapping, and the below one is the setting. So I think that's everything about the slides, and probably this is a final exercise you guys can try on your end. Maybe I can give you guys 3 minutes to work on it. So for this exercise, it's pretty straightforward description that we want to build a plot. We use a ggplot to construct the base plot, set the x as the highway and the y-axis as the city, and then set the points to be the CYL variable, like using it as both the shape and the color, and then set the same as the same BW, means black and white, and also set the GG title and also the subtitle. But if you run this function, you will see some kind of error saying, okay, a continuous variable cannot be mapped to the shape aesthetic. So basically, this is what we talked about before, that the shape and color, they are very suitable for the categorical variable. But here in the data frame, for example, MPJ, when we check the CYL the class, we see it's integer, which is continuous type of. So how to solve this problem is that we can consider to first convert the integer to a factor so that it is still categorical. So to do so, we can using the mutate function, right? CYL equals the factor CYL. So in this way, the CYL will be converted to a factor. And then we can, following the ggplot function, simply copy this part. And because we put it in the pipe, so we can remove the first argument and run it. So this will give us the desired plot that we specify the x and y axis, and also specify the color and the shape according to CYL variable, adding the black and white theme, and also adding the title and the subtitle. So basically, the only trick here is that you should convert the continuous variable integer into a categorical factor here. So with that, I think we finished our day one workshop. So for our day one is mainly just some kind of recap of data wrangling function, to introduce some useful tricks that you might be you might need to use in the following workshop materials. And in our day two, we will specifically talk about the different components of the ggplot2. And I will stay here for another 10 minutes. If you have questions, you are very welcome to ask. And if you don't have questions, you are free to go. And I will see you tomorrow.